create a learning ecosystem for every student. We are not talking about the top performer of the class. We are talking about every single student. And through the transaction done by the faculties and institute, we grab data and we process that data. And through this data, we give you a very useful insights and insight about the student, his performance on particular subject, unit, or particular lesson. So faculties can create a policy to work on every single student. That's how we were working on every single student, not a particular set of students. And here technologies plays a key part here, because this entire platform is built on strong math engine, and math engine help us to understand every single math, engineering, or science-based notation. And that's how we work on student learning experience. So how do we improve that? We have digital lessons. We create digital lessons, and these digital lessons, there are content in a text form, audio form, video form, the interactive narrative form, animation form, and that's how student get engaged with the sophisticated lessons. And at the same time, student get instant feedback from the platform itself, because my platform understand the every single science and math based notation. So that's how my platform gives you instant feedback about where you are doing wrong or where you have done right. So that's how we are working with the platform, and working for the students, and student can access these digital lessons sitting any part of the world. So that's how we are moving from a traditional teaching. And at the same time, we are giving faculties to the access of dynamic testing. We are offering more than 50 different question types. We are not limiting our platform to multiple choice question and fill in the blanks. And these 50 different question types are based on matrix based questions or differential equation based questions. So we are touching every sophisticated concept of maths and science. So that's how we are assessing a student, and at the same time, student get the grade of their testing immediately. So student can practice n number of times, and they can institute can take low stake examination, high stake examination through this platform. And at the same time, we are pulling out data from every single activity done by the student. So you have all these insights about a student. So that's how we are creating an ecosystem for a student learning ecosystem. And that's where CEMC help us. CEMC, they have open content available for maths and science based subjects. And with our powerful tool, this open content, which is available for the schools, we create a strong learning platform wherein the student can learn any complex concept of maths and computer-based subjects. So that this is all about digital education. And now I would like to call Mr. Ian Vanderberg to speak 5 minutes about CEMC and how this magical platform and courseware is changing student lives and their learning behavior. So over to Ian Vanderberg, and thank you everyone.
Thank you, Ujwal. Good evening, everybody in India. It is a pleasure to be here with you this morning. It's a sunny and warm morning here in Canada. First of all, I do want to say that Paul and I and so many of us here in Canada are watching the pandemic turn in India very closely right now, and our thoughts and our prayers are with all of you, with all of the challenges that you are going through right now, and we wish you a quick return to normalcy and health and safety very soon. So please stay well and stay safe as you can. We are here today, Paul and I, to talk to you about the CEMC, about the platform that we have, the open courseware platform that we have. And we're really excited to be part of mathematics education. Education right now in our world in the 21st century is so important. Mathematics is one of the most important subjects in all of this, because mathematics teaches our students to think in different ways and allows them to solve problems in different ways. And these are all such important things. The CEMC is based at the University of Waterloo, which is a large public institution in central Canada. And at the University of Waterloo, we have a faculty of mathematics, which is probably one of the largest collection of mathematicians in the world. We have 260 faculty members who teach the mathematical sciences. We have 9,000 students who study the mathematical sciences. And within that faculty, we have the CEMC, the Center for Education in Mathematics and Computing, which Paul and I work at, along with a number of other really committed educators. We are here to reach out to schools, to help students increase their interest, enjoyment, confidence, and ability in mathematics and computer science. We work with schools and teachers in Canada and a growing number of schools and teachers internationally. Mathematics and computer science are international languages. They are universal languages. While perhaps the names are slightly different for things that we use in Canada or in India, perhaps our approach to education is slightly different in India than it is in Canada. At the end of the day, the content is really the same, and it is this content that forms the basis for almost everything in our 20th century world today. The CEMC is really based on a model of working with schools and supporting teachers and providing opportunities and resources and activities for schools and teachers, whether they are in Canada, in India, or internationally. And this has been our model for more than 50 years of working with and trying to provide things to help you as teachers work with your students to encourage them to like these disciplines. Problem solving is at the heart of almost everything CEMC does, because problem solving is one of these parts of mathematics that is applicable in more than just mathematics. Problem solving skills are things that all citizens of the 21st century world need, whether they are in the arts, whether they're in business, whether they're in STEM fields. Problem solving skills that we develop in mathematics and that we here as educators teach in mathematics, these are what are going to help our students succeed. We really believe in a balance of the technical and the creative sides of mathematics. Mathematics is a funny discipline this way. We teach very specific things in the classroom and very granular things, but at the same time, what are we doing? We're really trying to help students mold their minds. We're really trying to help them learn how to think. We're really trying to help them learn these things. So we want to try to balance this. Mathematics can be seen as not a creative subject at all. We just follow these rules and we do these things. But it's those creative people out there who use mathematics and use mathematical thinking to develop vaccines, to fight climate change, to develop better cryptographic and security methods. These are the things that mathematics does for us. We believe in the balance of accessibility and challenge. We believe it's really important that all students have a chance for success in mathematics. And I think our courseware is one of the things that will really help many students do this, because it helps them outside of the classroom. We as educators in the classroom, we're committed to the success of our students and the learning of our students. By having resources available outside the classroom, students can go back and review, they can try, they can practice. And this is such an important part. Mathematics is a doing subject. We also believe very much in challenging the very brightest students in Canada and India and other parts of the world, in giving them opportunities through things like our contests and other things to get really interested in mathematics. We also believe in this balance of pure and applied. Mathematics is applied in the world, and that's important, but mathematics is also a beautiful subject. And trying to encourage students to see the beauty in mathematics just for the sake of the mathematics, knowing that many of them will want to go and apply it to other things. That's important too. Very quickly, the CEMC has a wide array of mathematics and computing contests written by students in more than 80 countries every year. We offer in-person and digital workshops and conferences to students and teachers. We offer digital resources like our courseware, and we offer an online master's degree, part-time master's degree for full-time practicing teachers. That's a really great opportunity for current teachers to think about the mathematics they're teaching in a different way and to improve their mathematics skills and hence improve their teaching skills. So Courseware, that's why we're here today. So why Courseware? Why did we do this? Why did we create these open resources that could be available for all students everywhere? This was a very expensive thing for us to do, for something that we get no revenue for. We wanted to do this because we want to support mathematics education. We believe in free, accessible, and high quality resources. I was speaking to a friend yesterday who had spent hours on the weekend Googling quadratic equations. She is not a math person. She was trying to teach her daughter, who's in year 10, trying to teach them quadratic equations. People spend a lot of time looking for resources like this. We have a one-stop place where they can come. They're free, they know they're good quality. The power of exploration. Textbooks, physical textbooks are great. They teach us good things. Through some of the online things that we can do, students can really explore, and they can learn by doing, and that's part of it. Algorithmic exercises. So Paul will show you some of this later on. Our questions, thanks to the back end of digital ed through the Möbius platform, our questions regenerate. A student tries it and they're not really sure if they got this right, if they understand this. They try another question, they try another question until they know what they're doing. We really believed as we were creating this in trying to set a tone and a level for mathematics. This is probably an issue in many countries in the world, and certainly an issue in Canada, because we don't in Canada, like you in India, most years have school leaving exams. We don't have those school leaving exams in Canada. And so this was part of what we wanted to do. But we also wanted to really explore the universality of mathematics and really take advantage of that. And this is so important. To do this, to create this course where we hired a number of really top quality educators, like my colleague Paul, who's about to share with you here, people who know mathematics, but also know pedagogy and know the classroom. And they developed an amazing suite of resources. And I'm going to pass back to Ujwal perhaps quickly, and then along to Paul to talk about the courseware, some very specific details. It's a real pleasure to be here with you today, and thank you.
All right, thank you very much. So now we're going to look more closely at what this courseware has to offer. So I'll start by giving a rough overview of what the courseware contains, and there's a lot of content, so that will lead us into a discussion of how the courseware is organized so that we can navigate our way around it. After that, I'll do a deeper dive into a few sample lessons to show you what's actually in the courseware. And after leading you through some examples, I'll briefly discuss the various ways that the courseware is being used already. Finally, I'll finish up by showing you a few neat features that will hopefully come in handy if you decide to make use of the courseware. I've put the link here that will take you to our main courseware page. And if you're able to open this up and follow along as we go, I would encourage you to, if you're able to do that while still viewing the presentation. But if you open that link, it'll take you to our courseware landing page. Put the link here again so you don't miss it. There you'll find sort of the main item on the page is this clickable graphic linking you to online courses in mathematics and computer science. These courses contain lessons, which are a combination of videos and text, and include, as Ian mentioned, a variety of interactive pieces to get students to actively engage with the content. They include tons of practice problems, both in the forms of those algorithmic questions, which are embedded in the lessons and provide instant feedback. And the algorithmic nature allows for multiple attempts with variation between attempts, but also end of unit questions, most often with answer keys and full solutions for more sort of pencil and paper type practice. Today, I'll be talking specifically about our mathematics courses, covering all of the topics that students in Canada would see in their grades 7 through 12 math courses. So this is the top 4 items in this graphic. I recognize that the curricula used throughout Canada will differ from what is used throughout India, but for the most part, I suspect this amounts primarily to a reordering of topics. And the way that the courseware has been set up, this shouldn't be an obstacle for you. Just for a bit more context, grades 7 through 12 in Canada roughly correspond to ages 12 through 18. Well, these top 4 items are going to be my focus today. I'll just very quickly mention that we do have this problem-solving course that was created by Ian which works through 160 fun and challenging problems to teach you sort of a variety of problem solving skills along the way. And on the computer science side of things, we also have courses in Python, web programming, and more. But getting back to grades 7 through 12 content, as Ian said, this has all been developed by school teachers working alongside faculty and staff at the University of Waterloo. And I should also give credit to, we had like an army of multimedia developers working with us to take care of many of the technical details and also to fine tune and bring to life our ideas for many of the interactive components. So let's talk about how the courseware is organized. There are slight differences between the grade 7, 8, grade 9, 10, 11, and grade 12 courses. So I'll just try to give a quick overview of what to expect in each case, beginning here with grades 7 and 8. When you enter the grade 7, 8 courseware, you'll see a list of units, and along with each of these units, there'll be a letter grouping them into strands. So these themes or strands are sort of the highest level, and within each theme or strand, we have a set of units. And within the units, you have all your topics making up that unit. These lessons for each topic are made up of short interactive videos, typically about 4 minutes in length. And there's exercises and, as I said, other interactive features embedded in those lessons. And I'll show you these things in a moment. There are also, with each lesson, there's a set of exercises and full solutions at the end. And then at the end of each unit, there's sort of a summative set of exercises, answers, and solutions. Let's have a quick look at this. So this is the courseware landing page, and here's our grade 7 and 8 page. And so this is taking us now into the Möbius environment. And here's our set of units. And what I was referring to with the strands or the themes are these letters like N and G, standing for number sense, geometry, algebra, data management, just to help sort of group these things. So once you select a unit, you've got all your lessons on the right side here. And I'll open one of these up in a second, but I'll also mention that we've also grouped the lessons as belonging to either part A or part B. And this is roughly corresponds to grade 7 and 8 here in Ontario. And I'll talk more later on about how you might use this if you were trying to build up a course using these lessons. Just to give you a quick preview of what a lesson looks like, we'll come back and look at more in a moment. But if you open one of these up, this is what appears. So we've got sort of this pane on the left-hand side for navigating the lesson. And then the main part of this is there'll be a set of videos.
Our ultimate.
And those will be narrated videos. And there'll be one of those that goes with each of these sections, and students would work through those. So the grade 9, 10, 11 content is set up in a similar way to the grade 7, 8 content with a couple key differences. First is we've actually created a separate page for the different strands, of which there are 7. And second, because the order in which topics are presented very significantly across Canada even, we haven't assigned lessons to a specific grade. So we haven't done like the part A, part B, to separate grades 9, 10, 11. So instead, we've taken more of sort of a fine grain approach to mapping the lessons to various curricula that are used across Canada. And I'll talk about that a bit more later on. But broadly speaking, if you want to find a lesson, you start off by picking the strand, and then a unit, and then a lesson. Another key difference that I'll mention here is that in addition to having sort of all the same interactive features and questions embedded throughout the lessons themselves are not just videos at this point. They're a combination of videos and text. But you have the interactive stuff embedded throughout both portions of the lessons. Another nice addition in the grade 9, 10, 11 content is that we also have an enrichment section that goes along with each unit. And so this will contain problems that are more like what you would see on a math contest versus what you would find in a typical textbook. So the grade 12 courseware is made up of interactive videos, and we've divided it into 2 courses. And the 2 courses together cover virtually all of grade 12 math, and actually quite a lot of what many students would see in their first year university math courses. Accessing one of these 2 courses from the main courseware page will actually take you straight to the set of units making up that course. So there are really only 2 levels in each grade 12 course structure hierarchy, in a sense. But otherwise, navigating them is very similar to grade 7 and 8. So what's contained in each lesson? So this is sort of this is the pane that we saw when I opened up on the left-hand side of the screen when I opened up a lesson a moment ago. So all of the courseware lessons will have will correspond to roughly 1 to 3 classroom lessons. And they'll have this sort of breakdown. So it'll begin with this sort of watch and read. And I like to say and do because there's a lot of interactive stuff in these lessons. This is where students are being presented with the new material in the form of narrated slideshows and texts and interactives. After that, there'll be a review, which will where usually we'll reproduce a lot of the questions and explorations from the lesson so that students can go back and work through that again. And then at the end, the practice is sort of like the pencil and paper type problems. Answers are provided for every exercise, and then full solutions are provided for all exercises in grade 7 and 8. For grades 9 through 12, we provide full solutions to the even numbered exercises. So there is the option to, for example, assign the odd numbered questions to your students and not have to worry about them being able to just pull the solution off our website. In the grades 7 through 12 courses, we also have these extra sort of features that recur through the lessons, the different lessons. So each lesson will begin with a section that we call, it's basically an introductory section. In grades 9 through 12, we call it Let's Start Thinking. And this is just to introduce the concept that's going to be explored in the lesson. And it'll include something that we call a try this problem. So this will be some sort of question to motivate the topic, and typically something that students that either really need to struggle with to solve before working through the lesson, or they might not really be able to figure it out at all at that point. But it's hopefully something that will pique their interest and get them to work through the lesson. And at some point through that lesson, we'll revisit that problem and show them how to solve it. And hopefully that'll be a bit of like a rewarding experience, and they'll recognize that they've learned something in that process. After that introductory part, so that the revisiting that takes place later on in the lesson. But after the introductory part, we actually have sort of the sections that make up the lesson. So this is where we'd have the bulk of the new material being presented. Within those sections, this is where you'll find items that we call either explore this or check your understanding alongside the exposition that's being presented. The explore this items are like guided explorations to create or manipulate objects, with always coming with a summary afterwards to sort of help students or anyone watching these to consolidate their observations. And so the idea is that hopefully you'll learn something new through discovery rather than just being told this. The check your understanding. So these are the algorithmic questions that we've been referring to. So this is a question that will be presented to the student to test their knowledge at a certain point, and there will always be feedback and a button that says, how did I do, so that you can check and see if you're correct. And most often there'll be a button that says try another, so that you can get a variation of that question and essentially get unlimited practice until you've mastered it. Our lessons also finish off with sort of a summary, and then what we call a take it with you problem that tries to get you to sort of motivate future learning about this topic. So it'll try to get you to expand on what you've learned in that lesson. I'll mention this alternative format feature later on, and I won't go into detail on these here. Okay, so without further ado, then let's look at a few example lessons. So how would this work if you were just trying to look up something for some material on some particular topic? So let's suppose that we were planning to teach students about diagonals and quadrilaterals. So this is something that shows up in grade 8 in Canada. So we would look in our grade 7-8 courseware. And how would we find that? So diagonals and quadrilaterals. We know we're looking in grade 7-8. And so once we get in there, we look through the units. We know that it's probably in the geometry strand. And it's probably, properties of shapes seems reasonable. And you can read through the lesson titles. It's also a good idea. Each lesson comes with a description because we might see quadrilaterals here, but then you read about it and you think this is too basic. That's not going to get into it. And then you notice, oh, there's actually one called diagonals of quadrilaterals. That's where we'd like to go. So in the grade 7-8, it's all short videos. And when you get in, so if we click play, I think you may be able to hear the sound.
Quadrilaterals are closed two-dimensional shapes that have...
So these are all narrated lessons. They begin with review if needed, and then go from there to introduce the new ideas. You can scroll through lessons, so if you're just looking for something, that's no problem. There's a couple other neat features I'll show you really quickly here. There's this film strip button, so you can basically, I've got a bunch of slides, and if I hit film strip, it'll spread them out vertically so that I can get a quick preview of what's on each slide. And there's this menu that allows me to jump between slides. So you can see this. If you can see this, it might be a bit small. So we've got like lesson goals, a few other things being introduced. This is all the motivation. And then at the end of the lesson, there's this try this problem. There's this try this problem. So here to get students to hopefully sort of start thinking about, if I give you the diagonals of a quadrilateral, you can actually figure out what the quadrilateral looks like from that. So that would be the introduction. Navigating forward, we get to the first section where sort of the bulk of the new content is being presented.
While we are...
I'll just pause that. And we can see looking through this, so there'll be slides where content is presented, but then there's these explore this pieces and the check your understanding pieces. So I'll show you what one of these looks like. So explore this.
In the following explore this.
So here we've got, it says basically investigate the properties of the diagonals of the parallelogram. So drag around vertices A and B and focus on the measurements of the diagonals. So these diagonal, the distances between the vertex and the intersection of diagonals is given. And if you start dragging that around, hopefully what students will notice is that the lengths on opposite sides of the intersection are equal to one another. And so then you don't really need to convince them of this afterwards. They've figured it out on their own. So there'll be a summary explaining this afterwards. And then eventually there'll be some sort of check your understanding type question, which tests them on it. And they get often much more sophisticated than this. Here we just have a basic true false question. Parallelogram diagonals do not have to bisect each other, true or false. And regardless of what they choose, they will get some instant feedback. And then they can try another. Each quadrilateral has two bisecting diagonals, and in this case, there'll be a pool of questions, but often the algorithmic questions are more sophisticated than this. Try and show you some of those later on. So anyway, this would finish off with a summary and that try this problem, as I mentioned. Maybe I'll just jump into that now, actually. So at the very end of the lesson, summary, some more, explore this and check your understandings, and then a take it with you. So this is to give the student something, a more sort of difficult question to expand upon what they've just learned. So I mentioned there was this final tab here called alternative format. So this is a really useful feature if you just want to quickly scan a lesson, or afterwards if you want to review it, or if you just prefer a text presentation. So basically the whole lesson along with the narration transcribed is presented at the end for sort of easy reference. And then there'll be some review questions and pencil and paper exercises, as I mentioned before. All right, so that's a grade 7-8 lesson. Let's have a look at maybe a grade 11 topic. So if we've been teaching trigonometry and we want to talk about, what happens now if we have an oblique triangle and we're trying to solve that triangle. So this is where you can run into what's called the ambiguous case of the sine law. So this is a grade 11 topic in Canada, at least. And we would guess that it falls under the strand that includes geometry and trigonometry, and that it's specifically trigonometry related. So then reading through the topics, I'll find, well, there's one here that deals with oblique triangles. So let's open up that lesson. So we're now in the grade 9, 10, 11 courseware. You can see there's some more there's a lot of interactives in this lesson that have been reproduced afterwards. And it starts off with a video that will motivate that lesson. The key difference here now in the grade 9, 10, 11 is that we have text going along with the videos. So after the video, you'll have lesson goals and you'll have questions and other content pieces that can actually be just presented in text form. So here we start talking about the ambiguous case of the sine law. So there might be a short example done by video, hoping that that will be an effective way to present that. And then check your understanding. So here's another simple one that's algorithmic, but here it says determine the obtuse angle theta with sine of theta equal to 0.83, right? And this is introducing the idea that, if they just use their calculator and the inverse sine function, they'll get a value of theta between 0 and 90 degrees here, and they have to find the angle supplementary to that. But if they, try it out and get it wrong, they can click try another, and it'll change this 0.83 to 0.89 or 0.9, 0.84, and get a new version of that question each time. Here's a need to explore this. So this is to get them to start realizing, why this ambiguous case of the sine law exists. So here we're presenting students with two side lengths in a triangle and an angle, and chosen sort of specifically so that we can ask them here, how many triangles can we construct given this information, and drag this point around. And they would realize, hopefully, that they can construct two triangles here, and we'll get them another to try out. And they can drag this around and realize there's what we call an ambiguity here. So this is summarized for them, and we sort of show, like, the potential pitfalls you can fall into when solving a problem if you don't keep this in mind. And then again, like more questions to check their understanding of the content. So they'll be presented with a triangle, and they have to determine all the side lengths. They can check how they did, and if they need to, they can try another and try again. And each time they can get a full solution. Continues on. They hopefully at this point are starting to realize, this side length here is sort of key in recognizing if there's going to be an ambiguous case or not. So in this explore this, they hopefully realize that, well, if this side length is less than h, I can't make a triangle at all. If it's equal to this height h, then I can make a single right angle triangle. If it's longer than the length b, then I can only make one triangle. And so this is the what to look out for when that side length A is between this length B and the height H. They'll hopefully realize that, oh yes, so this is what I need to be on the lookout for when I can potentially run into the ambiguous case of the sign law. So more practice, just testing for that, and the lesson continues. So as I mentioned, this basically just, this review section will revisit all the interactive pieces in that lesson. So here we just see, you can quickly jump to that content piece. All right, I'm not sure, I think I'm doing okay for time, but I'll just very quickly show you something in the grade 12. So in grade 12, suppose we're looking at trying to solve inequalities involving polynomials. This is a pre-calculus topic. So I could jump into the pre-calculus course and look for polynomials and inequalities and solving polynomials inequalities. And then I get a lesson. So this is the grade 12 course, and it's made up entirely of videos. And within those videos, that's where you'll find all the questions and other interesting content or interactive content.
In our second example, we are.
So you see here, there's a check your understanding. So these appear in the grade 12 course as well. I will jump ahead to the next point just so that I can get through everything. So how is this courseware being used? So talking to teachers around Canada, we find that it's being used in a whole variety of ways. And it's become particularly a useful tool for teachers during the pandemic, now that everything is remote. But it's being used for everything from, so, if a teacher is preparing a lesson, they'll just jump into the courseware, look for the courseware version of that lesson to get some ideas for bits and pieces to inject into their own lesson. At the other end of the spectrum, you might have teachers doing the whole flipped classroom model. So they'll assign the students to watch the courseware lesson prior to coming to class, and then when they come to class, they may just discuss it in more detail and or work on some problems to test their understanding. It can also be used, so we've got this enrichment material here in the grade 9, 10, 11, but also just, if you have a strong student, you want them to be able to work ahead, you can use this content for enrichment. If you're designing a course, this might help with figuring out pacing and organization. Or if you're teaching something you maybe haven't taught in a while, right? If you are being asked to teach about the ambiguous case of the sign law and you haven't seen this in a while and you wonder, what's a good way of presenting this? And how does it even work, perhaps? You can turn to the courseware yourself and go through it. It's also useful for helping students catch up. So I actually use this. So I teach a lot of first year university maths courses, and I get students that arrive and they maybe have gaps in their knowledge from the pre-calculus courses that they should have taken in high school. And so I frequently refer them to our courseware and help them sort of identify which topics they might need to revisit or even see for the first time and get them caught up that way. And of course, you could just look at the questions and get ideas for homework or assign them directly. So in the last section, I wanted to talk about a few neat features that the courseware has that might help you with building up your own courses. In the grade 7, 8, so we have this, if you were trying to teach a particular topic, so I'll go visit this on the actual site. So we're in the grade 7 and 8 courseware, and below all these units, there's this item, course information. And then within that, there's this prerequisites piece. So this gives you this sort of hierarchy tree that would help you figure out in what order to present topics to make sure that you've taught everything you need to, everything that a given lesson depends on has been covered before getting to that lesson. So if I wanted to teach a particular lesson from the data analysis unit, I would have to make sure that everything feeding into that I've covered the lessons feeding into that first. And because we've divided into part A and part B, you actually only need to worry about, if I'm teaching a part A lesson from data analysis, I only have to teach all the part A items from the units feeding into that. So it gives you a whole bunch of flexibility basically in how you decide to present the material. I mentioned for the grade 9, 10, 11, we had these curriculum mappings. So this is how teachers figure out what content to teach in Canada and in the US if they're using the courseware. So from the grade 9, 10, 11, these curriculum maps can be accessed here. This might not be immediately useful to you, but if a teacher in, say, Ontario, this province of Canada, wanted to teach grade 9, they'd recognize this as the code for their grade 9 math course. And they could click on this to get, basically here's all the lessons for their grade that would make up their grade 9 math course. And so they could piece it together that way. So we have this done all for Canada. We actually have it done for the US Common Core as well. And I imagine, so I can't commit to anything because this is not in my wheelhouse, but I imagine if there was significant uptake in India in terms of usage of our courseware, this is potentially something we could do for India as well. And so finally, I'll finish off with this interactive library piece. So for both grade 7, 8 and grade 9, 10, 11, we have these interactive libraries. So I'll open this up for grade 9, 10, 11. So from the grade 9, 10, 11 landing page, we've got the interactive library. And this is a way of basically searching for all the interactive components. So these are the explore this and the check your understanding algorithmic questions. And you can search by actually picking out a lesson, so strand, unit, down to a lesson and searching, or you can just put in a keyword here. And so the idea is, maybe you worked through a lesson and you saw something interesting and you can't find it now, or you're starting to teach about something and you want to find some cool interactives to share with your students. Oh, I'm sorry. So here you can just type in a keyword. So maybe we're talking about similarity, and we can then scroll through and sort of preview all the interactive pieces. So here we're being asked something about similar triangles. Again, about similar triangles, and scroll through until you find something that maybe is interesting to you. So here, I want to talk about scale factor. So once you find something you like, you can actually just click on it from here, and it'll take you straight to the lesson where that item is used. All right, and so then you can play around with this. And here we have this piece where we can actually drag it. Let's see how we do. Try another, keep trying. Okay. All right, so that's everything I'd like to show you today. We've got some time for questions. While that's taking place, I've also highlighted some examples from the grade 9, 10, 11 courseware for you to check out. I should confess I've only picked the grade 9, 10, 11 courseware because that's what I'm most familiar with. I helped work on it. But please feel free to also explore grade 7, 8, or grade 12 courses and ask us any questions that you have. So thank you very much.